Hey there, how's it going everybody? In this video, we're going to set up an IPsec VPN between two Juniper SRXs using pre-shared key for authentication. This is the short version for those of you who are comfortable with IKE and IPsec concepts and don't want explanations of how they work and interact. If you're looking for those explanations, then check out the long version of this video on my channel. Alright, let's look at the topology. As you can see, the topology we're working with is pretty straightforward. Both SRXs are connected to the internet and can reach each other's public IP. The dashed line represents the IPsec tunnel that we're configuring. We're going to configure it as route-based, since that's more flexible than policy-based and should be used whenever possible. In addition, we're going to use IKE version 2 instead of the depreciated IKE version 1, which was formerly known as ISACAMP. Let's also bring up OSPF across the tunnel and ping between the two loopback IPs. This will verify that the IPsec is up and routing. The IPsec VPN configuration on the SRX can be broken up into three parts: IKE, IPsec, and the route-based elements. Those parts can be further broken down into three parts each. Starting with IKE, we first have the proposal, which are the IKE settings we're telling our peer that we want to use for the IKE tunnel. Second, we have the policy, which references the proposal and is where we configure the pre-shared key for authentication. Third, we have the gateway, which references the policy and is where we configure the peer IP, the anchoring interface, and the IKE version. Moving on to IPsec, we first have the proposal, which are the IPsec settings we're telling our peer that we want to use for the IPsec tunnel. Second, we have the policy, which references the proposal and is where we configure perfect forwarding secrecy. Third, we have the VPN, which ties everything together. It references the IPsec policy, it references the IKE gateway, and it references the tunnel interface. Finally, we have the route-based elements. First, we have the tunnel interface configuration. Second, since this is an SRX, we need to place the tunnel interface into a security zone and make sure our security policy is permitting traffic flow. Lastly, we need to configure our routing protocol to run on the tunnel interface. Let's jump into the CLI and see what this looks like. So here I am on SRX0. Let's take a look at routing, get our bearings. Alright, so here's my loopback 0.0 interface with my loopback IP of .20. Here's my gig 0.0.0 interface, and you can see here's my IP, and here's the subnet that connects me to my ISP. Here is my default route that's pointed out my internet interface and is next hopping to my ISP. So this looks good. Let's see if we can ping the other side, if we can ping our peer across the internet. So let's take a quick peek back at the topology. Our peer was 43.164.20.254. Let's see if we can ping that. Yep, we can ping him. So we have the reachability in place to begin the IPsec configuration and bring up the tunnel. So let's jump into configure. And now the IKE and IPsec configurations are going to happen under the security section. So here you can see the proposal. We're going to configure it, and let's give it an obvious name like IKE prop. The first setting we're going to set, and remember these are the settings we're offering to our peer to set up the IKE tunnel, is the authentication method, which is going to be pre-shared key. Second is going to be the authentication algorithm, which is what's going to be used to hash the pre-shared key before we send it to our peer for authentication. Next, we're going to configure the encryption algorithm. This is what we're going to use to encrypt the IKE tunnel. We're going to go with AES 256. Speaking of encrypting the Ike tunnel, we need to have a key to use with this encryption algorithm. We derived that key from Diffie-Hellman. I'm going to use group 14, which is a 2048-bit key. I wouldn't recommend using anything smaller than group 14. Any weaker group. Finally, we're going to configure the lifetime. Now, the lifetime, I'm going to go with 86,400 seconds, which is the maximum value and happens to be 24 hours. So no matter what, every 24 hours, Diffie-Hellman will be rerun and a brand new key will be derived and will be used with the encryption algorithm to encrypt our Ike tunnel. So every 24 hours, our Ike tunnel is being rekeyed. All right, so let's move on to the next step. We're done with the proposal. Let's configure the Ike policy. And let's name it something obvious, like Ike Poly. Now here, we need to reference the proposals that we just configured. Next, this is where we actually set the pre-shared key. So we chose with the proposal that the method was going to be pre-shared key, but here's where we set what the pre-shared key is. Now I'm going to go with $capital RX1 lowercase key spelled with a 3 bang. Now this is all we need to configure for the policy. We're using Ike v2, so we'll always be in quick mode. So this mode is actually only for Ike v1, where you get to choose aggressive or main mode. And we don't need to set the certificate because we're not using certificate-based authentication. All right, so let's move on to the gateway. Now we're going to call this gateway something obvious, like SRX1, since that's who we'll be connecting to. Now the first thing we're going to want to do is reference the Ike policy. Next, we're going to want to point to our peer address. Now let's scroll up here and grab the IP that we pinged, and that'll be our peer address. That's where we're going to send the Ike packets and eventually the IPSec packets too. Next, we need to pick our external interface. This is where the Ike and IPSec tunnels will anchor. And almost always it's going to be your physical interface that's facing the untrusted network, in this case the internet. But sometimes it can be a loopback if you have multiple interfaces going to the untrusted network and you're load balancing or doing some sort of failover. And finally, under the gateway, we're going to set the version to v2 only. All right, so Ike is now done. Proposal's been created with the settings that we want. The policy references the proposal and has the pre-shared key configured. And the gateway references the policy, points to our peer, SRX1, is going to be anchored on our internet connected interface, and we're running version 2 only. Let's move on to IPSec. So the first thing is proposals, and we'll name it something obvious. Now here, let's start with the protocol, which we're going to choose encapsulated security payload. Next, let's choose the authentication algorithm. We're going to go with SHA-256, MD5 and SHA-1 are depreciated. Next, we're going to go with the encryption algorithm. And here we're going to go with AES-256. And finally, we're going to go with the lifetime. And this, I'm going to make shorter than the default value. I'm going to make it 28,800 seconds, which is 8 hours. So our IPSec tunnel will be rekeyed every 8 hours. And those keys will be exchanged through the encrypted Ike tunnel. So we're done configuring the proposal. Let's jump to the policy. We'll name it Ike Poly, and it needs to reference our proposal. The only other thing we configure here is whether we want perfect forwarding secrecy, which we do, and it's going to say which keys, and we're going to stick with group 14. Just a quick reminder, perfect forwarding secrecy is an extra security step Since the IPsec tunnels share their keys through IKE, if a bad actor were to compromise your IKE, then every time your IPsec tunnels rekey, they would see those keys. Perfect forwarding secrecy means that every time it's time to rekey IPsec, in this case every 8 hours, it rekeys IKE first. It reruns Diffie-Hellman, derives new, in this case, group 14 2048-bit keys, and rekeys IKE. Then each side sends new keys for IPsec. So that timer we set earlier, that lifetime of 24 hours for IKE, actually isn't going to come into play because perfect forwarding secrecy is going to rekey the IKE tunnel every 8 hours when IPsec gets rekeyed. All right, let's move on to IPsec VPN. Now we're going to name this SRX1 because that's where our VPN is going to. So the first thing here we need to reference, let's reference the IKE gateway, which we also called SRX1. So this is what ties IKE to IPsec. Next, let's set the DF bit. We're going to set it to copy. All right, the next thing we need to do is set the IPsec policy, which was IPsec poly. Finally, we need to set this to reference our interface. So we're going to say bind interface, and this is going to be 21 if we just quickly look back at the topology, secure tunnel.21. So now the VPN is bound to the IPsec policy, to the IKE gateway and all of its policies and proposals, and to this tunnel interface. So now let's configure the tunnel interface. First, we'll give it an obvious description. We're going to SRX1. Next, we'll go ahead and set the MTU to 1400. Then we're going to configure the address, which is going to be 172.16.21 and .0 on our side, /31. All right. Next, we need to look at our security zones because this is an SRX. So you'll see we have our internet security zone with our internet interface, and then we have our corporate security zone, which is where our loopback is. And this is where we want to put our secure tunnel interface. It's going to be in the same zone, and it's going to allow us to ping intra-zone between the loopback and the tunnel. I should quickly mention that to make the lab easy, I just went ahead and said default policy permit all. So right now we're permitting all traffic in all directions. All right, now let's do the final step for route-based VPN, which is running our protocol. We'll just do single area, area 0. First, we'll put the loopback interface. We can make it passive since no neighbors, so no need to send hellos. And then we'll configure the tunnel interface. So let's do a commit check. All right, and let's commit this down. Alrighty. So before I move on to SRX1, let's look real quick and see what IKE and IPsec look like when it's not working, because part of this is verification. So show security IKE, security associations. So you can see that it knows it wants to do something, right? It's trying to talk to the remote address of SRX1. It's trying to run IKE v2, but it knows that it's down. If you look at the details, you can see it's working over UDP 500. It sent one packet. Nothing has come back. It knows it's doing pre-shared key for authentication. Let's take a look at IPsec. So IPsec won't show anything because IPsec spawns off of IKE. IKE is down, so IPsec hasn't spawned. But Juniper has a cool command called inactive tunnels. These are all the IPsec tunnels that are configured to be up, but are for some reason down. So you can see here we do have an inactive IPsec tunnel, and this SA not initiated is just simply referring to that for whatever reason IKE has not initiated or spawned the IPsec tunnel. So this tells us something's wrong with IKE. All right, so let's move over to SRX1. Let's take a look at routing. All right, here's my loopback interface. with my loopback IP of .21. Here's my internet interface on gig 000 with my internet IP and the subnet I'm using it to connect to my ISP. And here's my default route, and it's next hopping to my ISP and exiting my internet interface. We already know that we have reachability, so I'll skip over the ping test. Let's get into configuring. Now, we already have the configs going on SRX0, and so we can use those same configs with some small tweaks. So I'm going to jump back to SRX0, and we're going to copy out all these IKE commands. And I'm going to do this in Notepad off screen, but I'm simply going to rename the gateway to SRX0, and I'm going to rename the address to SRX0's internet address. All right, let me get this pasted in, and let's take a look. So on SRX1, we now have our IKE pasted in. I renamed the gateway to SRX0, and I renamed the address to SRX0's internet address. Let's do the same thing for IPSec. We're going to copy all this out. And let me get that pasted in, and let's take a look. So these commands came from SRX0, but I renamed the VPN to SRX0, and now I'm referencing our local IKE gateway SRX0. So we'll do this one more time, this time for the interface. And this one I don't have to go off screen. I can just simply paste this in, but before hitting return on this last command, the address, I'll just change it to .1. And I'll update the description to 0. And the rest we'll do by hand. We'll set the security zone, corporate, and we'll add our interface, our tunnel interface .21. And I'll quickly check that the policy is set to default permit all. And finally, we'll do the OSPF, single area 0, and we need it running on the loopback interface, because that's where our ping is going to originate from, and the tunnel interface. Let's do a commit check, and that checks good. So let's go ahead and commit this. Now both sides are configured for this IPsec tunnel to work. Let's see if that's the case. So already things look different. Now we're looking on SRX1 side, but you can see that it sees the IKE tunnel is up to this remote address, which is SRX0, in version 2. If we look at the details, notable things to point out are that it recognizes we're doing pre-shared key, that we're using UDP port 500 to reach our remote peer. Here's the IKE proposals, the settings that we configured. And here's the mode I was talking about. IKE v2 only has one mode, which is quick mode. All right, let's take a look at IPsec. So you can also tell this is different. We have a total of one active tunnel, and here's the two security associations. You can see our settings in the IPsec proposals. And under detail, you can see that it's IKE v2 that we use to spawn this IPsec tunnel. We set the DF bit to copy. Here's our tunnel interface .21. And again, here's the IPsec proposal settings that were agreed upon. So now let's see if OSPF came up. And it did. So you can see the router ID of SRX0 was in fact .20. We're up on the tunnel. And there's the tunnel IP of SRX0. Let's take a look and see if we're learning the route we need to be learning, which is SRX0's loopback IP, and we are, via the tunnel interface. And you can see we've been up for 1 minute and 30 seconds. So the final check is to send traffic. So we're going to ping SRX0's tunnel interface, loopback interface, which is .20, and source it from our loopback interface, .21. And this is going to go through the tunnel. And it's a success. So there you have it, folks. how to configure a route-based IPSec VPN between two SRXs using pre-shared key for authentication. Do me a favor and like the video if you found it helpful, and subscribe if you're interested in seeing more. Thanks for watching.